Hi Pre-Calculus kids. Today I want to show you some practice problems from section 12.1 on the law of sines. This is what the practice page looks like. It's a little different than normally what they publish with our notes. And in fact, they call this an Algebra 2 topic, but some classes teach it in Algebra 2, some teach it in Pre-Calc. It's fine. This is all good. So we're going to solve these triangles. And if you remember from the examples that I showed you in the introduction, we're going to start by drawing our triangle. So I'm going to pick and choose. I kind of looked at the answers after I made the answer key and picked the ones I thought you might have most difficulty with to give you a little variety. So number 4 is one of the ones that I want to do. I'm drawing a triangle. It's triangle EFD. They can call it whatever they want. Here's my triangle. I tend to go in alphabetical order. So here's my D, here's my E, here's my F. Does not matter, you're just drawing your triangle. So E is 71 degrees. 71 degrees. Little d is opposite angle D, so that's 34. And little e is opposite angle E, so that would be 33. You're looking for, remember the law of sines says, the sine of A over little a, its opposite side, equals the sine of B over little b, equals the sine of C over little c. They're all proportional to one another, and you're picking two fractions to set up your ratio so that you can figure out what the opposite side would be, or the opposite angle. So they told us two things about E. That's how I'm setting my first fraction. The sine of E, 71 degrees, over little e, 33. They told me one thing about D, so I'm going to go for finding angle D. So the sine of D, little d is 34. And then I go to my calculator, making sure that I'm in degrees, and I figure out what's the sine of 71 degrees. And I round it to 2 or 3 decimal places, something like that. I get 0.95 over 33 equals the sine of D over 34. I am going to cross multiply, so 0.95 times 34 divided by 33 is what the sine of D equals. Sine of D is 0.974. And then I want to know what the angle is, what the reference angle is. So I do second sine, 0.974, and I get a reference angle that's 76.9. You can keep it as 76.9 is just fine. So here we go. D equals 76.9. If you want to round out to 77, that's fine. It's all in the neighborhood, right? So I know what the angle is. Remember the sign, because all students take calculus, could be positive in the first or the second quadrants. So I'm doing 76.9 degrees is what it is in the first quadrant. If it were in the second quadrant, it would be minus that. I get 103.1. Now I've got to look at what I've already got in my triangle. If I have 71 degrees already there, and I add 76 to it, is there enough left for me to have a third angle? Remember, they have to add up to 180 degrees, so 180 minus 71 minus 76.9. Yes, there would be enough for a third angle. And so then I'm going to go over to my 103 angle that's here. And if I have a 103 angle, I end up with 71 plus 103 is 174. I have room for a third angle. It's going to be small, but I've got room for a third angle. So this is one of those that has two cases. Case number 1 and case number 2. I showed you these in the introduction video also of how this can happen. Case number 1 is if angle D is 76.9, and case number 2 is if angle D is 103.1. Well, I know what angle E is. This is angle D. So I can keep it consistent here. Angle D equals. If I have 76.9, I know angle E, I know angle D. That means angle F is left. So I take 180. Use my calculator. If I take 180 minus the 71 I already had in the triangle, minus the 76.9, and that leaves me with angle F being 32.1 degrees. If I do the same thing over here, I have 180 degrees minus the 71 that was, minus the 103.1, and I get 5.9 degrees. So now I have all three sets of angles. I know what little e is, I know what little d is, and I'm looking for little f. So I'm going to set up a proportion. I usually go back to this very beginning one. Sine of 71 over 33 equals the sine of, I'm looking for little f, so I'm going to use f here, 32.1. I know this, 71, sine of 71 is 0.95. I know that the bottom is 33. I do not know the sine of 32.1, so I'm going to get that. 0.53 over f. So I'm going to cross multiply. 0.53 times 33 divided by 0.95. I get 18.46. So if angle D is 76.9, angle F is 32.1, then little f is going to be 18.46. If I come over here and do the same work, I'm looking for little f, but I want little f when the angle is 5.9. So my work is going to be exactly the same. The sine of 71 over 33 equals the sine of 5.9 degrees over little f, which is what I'm looking for. All right, so I already know the sine is 71. The sine of 71 is 0.95 over 33. I don't know the sine of 5.9, so let's get it. 1.03, or I'm sorry, 0.103 over little f. If I take that times 33 divided by 0.95, that gives me my little f. Little f would be 3.57. All right, so that is the answer to number 4. Now let me show you something just so that you know. When I did the answer key, this is the same problem, if you can kind of follow here. Here's number 4. I got slightly different answers for this one. I got, if you look at this, angle D, I got 78.5, and that made my angle F 30.5. If you look at where we were, that's here. So I got 78.5 for this guy and 30.5 for this guy. What's the difference between these two? Is one of them right? Is one of them wrong? And the answer is it's all about the rounding. So in this one I rounded it slightly differently, but I'm in the neighborhood. I'm within a couple degrees both ways. And it also is going to end up affecting your little f answers as well. So you need to be in the hood to be good. I mean, we've talked about that before with other problems. So don't let it, you know, if you are slightly off my answer key, fine, you're good. You should just be on my street, okay? So number 4, that takes care of number 4. Number 5 is the next one that I wanted to do. Number 5, I'm going to draw a triangle. I'm back to ABCs. Here's my A, here's my B, here's my C. A is 82. Little a is 19. Little c is 9. They gave me two things about A, so that's how I'm going to start my law of sine. Sine of 82 degrees over its opposite side, 19. They told me something about C, so I'm going to go for angle C. The sine of C over 9. I go to my handy-dandy calculator and I figure out what the sine of 82 is. Let me move this over a little, you can see it all. Sine of 82, 0.99 over 19 equals the sine of C over 9, cross multiply, 0.99 times 9 divided by 19 gives me 0.469. Alright, so I go for 0.469. I want to know, that means sine to the negative 1. I'm looking for the angle of 0.469. It's going to give me my reference angle. Second sine, 0.469 gives me 27.9. Well, is it close enough to 28? We'll say 28. 28 degrees. Now, remember that can be in the first quadrant. I've lost you on my writing. That can be in the first quadrant or it can be in the second quadrant. So let's see what that looks like. Here we are. If I'm in the first quadrant, it's exactly the same as the reference angle. If I'm in the second quadrant, it's 180 minus that value. That would be 152 degrees. Well, let's think about would that work. just like we did in that number 4 problem, right? If I have 28 degrees plus 82 degrees, I'm at 110 degrees, and so that means that I've got plenty of room for a third angle. If I'm at 152 degrees and I add 82 onto it, now I'm at 232 or 234. That's way too big. So this one I can eliminate. This is not a case 2 situation. This is just one case. So I've got one situation where the angle for this one, for angle C in this case, will be 28 degrees. All right, so let's see if we can finish solving the triangle. I know angle C is 28 degrees from my work right here. It can't be the second case scenario, 152. That means that I have angle B. If I add these up, 82 and 28, I end up with 110. That leaves me 70 degrees left for angle B. And now I know all of the angles, but I don't know what little b is, and that's what I'm going to find. So go back to your original fraction, the sine of 82 over 19 equals the sine of angle B, 70, over little b, because that's what I want to find. All right, so if I look at that, I know what the sine of 82 is. It's 0.99. I don't know the sine of 70, so I go to my handy-dandy calculator, and sine of 70 is 0.94 over little b. I cross multiply 0.94 times 19 divided by 0.99, and I get a little b that is 18.04, or something close to that. All right, so there's a situation where it's only one possibility, even though you did find the angle and you found the reference angle in the second quadrant, but it was too big to fit into your triangle to give you room for a third angle. So that's number 5. We've got a couple on the back side. Numbers 9 and 12 are on my list, so let's check those out, see what happens with them. Number 9, it's still triangle ABC. They called it CAB. What does it matter? It's still triangle ABC. Angle C is 73. Little b is 30. And little c is 26. What did they give you two things about? Letter A, letter B, letter C. They gave you two things about C. So start your proportion that way. The sine of 73 degrees over 26. They gave you one thing about B, so go for angle B. Sine of B over 30. Then you go to your calculator, and for the sake of time I'm just going to tell you what you can calculate them out on the calculator. You've seen me how I do that. So sine of 73 is 0.96 over 26. Sine of B is the sine of B over 30. I cross multiply 0.96 times 30 divided by 26 gives me the sine of B equals 1.11. And so that means I go to sine to the negative 1 of 1.11, and guess what? It gives me an error. And remember, I talked about this on the intro video. The reason why that's an error is because if you think of the sine graph, the tallest it goes to is 1, the lowest it goes to is negative 1. You're not going to hit 1.11 because it doesn't go that tall. So this one is a not possible. You can't have a triangle with those dimensions. So there's one of those that's a not possible. So we kind of talked about this. You're going to have either not possible as your answer, you're going to have one answer, or you're going to have two answers for them. It's either none, 1, or 2 for all of these problems. Let's go to 12, our last one. Number 12 is kind of interesting, and the reason I'm choosing it is because it looks like you get an answer, but you really don't. And you're going to say, well, what are you talking about? But let me show you how it works. I got triangle STR. Again, I tend to put them in alphabetical order. Here's R, here's S, here's T. S is 155. Yes, I know that I'm drawing that as an acute angle. It's okay. Little r is 25. And little s is 25 as well. All right, so I go through the work. They gave me both things about s. That's how I'm setting up my fraction. Sine of 155 over 25 equals, and then on the other side, I know one thing about r. So the sine of r over 25. And so I go through the math of this, and the sine of 155 is 0.423. 25 equals the sine of r over 25. And so I cross multiply 0.423 times 25 divided by 25. Guess what it puts you back to? 0.423. Sine of r equals 0.423. So if you go to your calculator and you think, well, geez, let me figure out the reference angle for that. This is 0.423 in here. What's angle r going to be? Well, my reference angle actually comes out to be 25. Which means we put it in our quadrants. It's either 25 degrees or it is 155. 155 degrees. Now looking at this problem, it would look like this is a two-case, well, it would look like it's 25 degrees, right? Because I have 155. If I use 25 as my other angle, if this really is 20, well, this angle here could either be 25 or it can be 155. Will that make sense? If I take 155 plus 25, I end up with 180. There's nothing left for that last angle to be. If I do 155 plus 155, I'm well over 300 actually with that one, right? So that's not going to make any sense. So both of these answers don't work in the problem, and this guy's going to be a not possible. Here's another thought you could have with that. If these two sides are equal, then what kind of triangle is it? And hopefully you remember from geometry, if this side equals this side, then that is an isosceles triangle, two sides that are equal, which means these base angles have to be equal. That's one of the properties of an isosceles triangle. If this one's 155, then this one will have to be 155, and that obviously can't happen because your triangle can add up to only 180 degrees. So lots of different ways to look at this one, but this one is one where that's not going to be a possible situation because neither angle lets you have room for a third angle in the triangle. All right, so there's your examples. You can email me if you've got any questions or problems. There are 3 sections to this unit. This is section 12.1 that you'll be able to finish now. Section 12.2 is on the law of cosines. Very similar, just a different formula. And the 3rd section is on how to find the area of triangles using these law of sines, law of cosines types of things. So they're all relatively easy. It's just a matter of the formulas that you're going to use. And then we're going to be testing out on this unit by June 9th. So that's our target date, and if you have any questions or problems, send me an email. And I miss you guys, and I'll talk to you soon. Bye.